Hi, my name is Anna, and I'll be talking about our paper, Perceptions of the Fairness Impacts of Multiplicity in Machine Learning. Machine learning is used in a lot of high-stakes settings. For instance, a bank might use machine learning to determine which loan applicants will get the loan. Hospitals might use machine learning to triage patients and determine who needs access to additional care. And companies use machine learning to screen resumes and decide which applicants to interview. In each of these settings, the entity deploying the machine learning model will train a model on available training or validation data and typically select the model that obtains the highest accuracy. So here I'll think about the banking example. So let's suppose that the most accurate model the bank can find gives 80% accuracy in predicting which loan applicants will default or not. Then when a new loan applicant comes along, the model can make a prediction. So maybe in this case, it predicts that this person shouldn't be given a loan. But research in machine learning has shown that this model here is oftentimes not unique. That is, there's likely a second model or third model or lots of other models that also achieve 80% accuracy, but do so in a different way. So in this example, maybe there's another model that has 80% accuracy in aggregate, but this model says that this man should be given a loan. This phenomenon is called model multiplicity. And it's really common in machine learning. And research in machine learning and research in philosophy about this topic have posited that this poses a fairness issue. So in particular, from the perspective of the decision subject here, if the bank goes with the first model that denies the loan applicant this opportunity, it's hard to provide justification for why one model was arbitrarily chosen over the other, especially from this man's perspective if the second model is giving him like a more desirable outcome. However, no one has really looked at this other than from an expert computer scientist or philosopher point of view. So in this study, we investigate how multiplicity impacts crowd workers' perceptions of machine learning fairness and how they want decisions to be made when multiplicity exists. We look at a few research questions. First, does multiplicity affect participants' perceptions of the fairness of a machine learning system? Second, which techniques to resolve multiplicity do participants prefer? So that'll be how should we actually make decisions when there are two good models that disagree on a prediction? And then how do the previous research questions vary based on task characteristics? I'm not going to talk about this third research question in this talk, but if you're curious about what tasks we used, you can check out the paper. We used survey-based methods. So the first thing we did is a preliminary study that helped us choose which tasks to use. Again, more details on that are in the paper. And then in our main study, there were two parts. The first part investigated how multiplicity impacts the fairness of a machine learning system. And here we started off with education about what multiplicity is, followed by a comprehension question to check that our education was effective. Next, we asked participants to respond to a series of Likert scale questions about using machine learning in a specific scenario. After that, we tell them that multiplicity exists in this system. That is, there's some other highly accurate model that disagrees on certain predictions. And then we ask them to give the fairness perceptions on that set of Likert scale items again. Our hypothesis for this part of the survey was that stakeholders would view machine learning systems as less fair once they were made aware of multiplicity. And this hypothesis was not supported. In particular, we didn't find any change in fairness perceptions after telling people about multiplicity. The second part of the survey looked at how people wanted multiplicity to be resolved. So we asked people if there are two models and they disagree, we're going to give you two options for how decisions can be made in the case of disagreement, and you can choose between them. So for instance, one option might be to choose the outcome randomly, so essentially flip a coin when the models disagree. And the second option could be defer to a human employee, and maybe that one comes with an additional auxiliary cost. And so people saw several of these randomly generated binary choices. And our hypothesis here was that they would have opinions on how multiplicity is resolved. They would choose different options with different frequency. And in particular, we thought they would view deferring to a human decision maker as the fairest solution and randomly choosing the outcome as the least fair solution. And this hypothesis was supported. I'm going to dive into this result on the next slide. So what I'm going to show you is called a marginal means plot. So on the left, we have all of the different ways that multiplicity can be resolved. And now I'm going to show you the graph. So in this graph, the x-axis is the probability that each option on the left was chosen in a one-to-one matchup with any of the other options. The red line in the middle corresponds to 0.5, or just random chance of choosing that option. And what I want to highlight first is that people choose deferring to a human expert about 80% of the time. And this is significantly more preferred than any of the other options. And second, randomization is preferred less than 30% of the time. And this difference is statistically significant for everything else except defaulting to the bad outcome. So overall, we investigated how multiplicity impacts crowd workers' perceptions of machine learning fairness and how they want decisions to be made when multiplicity exists. So as a recap, this is the setting we start with. There's multiple models, they disagree on some predictions, and the premise, at least from existing machine learning and philosophy research, is that this setup is unfair. We have two takeaways I want to discuss. The first one is that there are some mismatches with the existing research on multiplicity. And the second takeaway, I want to highlight some opportunities for future work. So our first mismatch with research on multiplicity is that we found that randomization isn't viewed as fair. And so in particular, the philosophy literature on model multiplicity proposes randomization as the fairest outcome, sort of drawing parallels to lotteries. And in general, lotteries outside of a machine learning context, lotteries are viewed as a fair decision-making mechanism. So it's really interesting that we didn't see the same result of combining kind of a lottery system with a machine learning system. What we think is happening here is that even if people are comfortable with lotteries in general, they think that machine learning models should be more sophisticated. The second mismatch with existing research on multiplicity is that our results indicated that multiplicity doesn't impact fairness perceptions of a machine learning model, even though we have this kind of like preconceived notion in the existing literature that it is a fairness issue. This is a nice segue into the first opportunity for future work, which is that context matters. So in our survey, we found that in order to reduce the cognitive load for participants, we wanted to abstract away as many other details. So like, are explanations present? What are overall fairness scores? Thinking about demographic groups. What is the overall accuracy? What are opportunities for recourse or accountability? We abstracted all of those things away so that we could teach people about multiplicity without just overwhelming them with information. But we think what might have happened is that without all of that context, people sort of viewed the machine learning model as sort of an inscrutable black box. So having multiplicity didn't really change the fairness perceptions because they weren't really sure what to make of the model in the first place. An opportunity for future work then is to look at a real-world machine learning system with users who already are familiar with all of those auxiliary pieces, and then tell them about multiplicity. We'd be really curious to know what results that yields. Second, our results indicated that deferring to human is the preferred multiplicity resolution technique, but there are some open questions here of what this means for using machine learning, because a lot of times if someone's using machine learning, it's because they want to sort of like save money, save time, as compared with having humans make the decisions. So I think it's an interesting direction to sort of study if there's a lot of multiplicity, is it appropriate for us to be using machine learning? The full paper is at the QR code, and thank you for listening.